All right, we are in AP Calculus. We are on lesson 4-2, tangent line approximations. I am your host, Mr. Sindel. Today's date is November 3rd, 2020. Our objective, Fiona, is to all right. So let's read our problem, Andrea. There it is. So let's analyze what information is given to us in terms of the notation that you might see on an AP text. So let's go ahead and say we have a function of snow. So I'm going to say S of something. I just randomly made up that letter, right? So I'm going to say S of maybe T. T is equal to some equation, blah, 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 blah. What information is given to us in terms of S? Capital S of something is equal to something. That information has been given to us. And we'll say T represents days. So for example, first day, I can say first day would be 1 day. So S of 1 would be equal to what, Fiona? S of 1 is equal to 18. So this is the type of information that you'll probably see on the AP test, but I like making word problems too. So we learned point slope form yesterday. Is that right? Point slope, point slope, point slope. So we're basically ready to make the tangent line right now because we have an X coordinate, we have 1, we have a Y coordinate, we have slope, a rate of 12 inches per day. Whenever you see anything that says rate or speed or velocity, anything like that, that will always mean slope. So let's set up our general formula. So it's going to be y minus box is going to be equal to box times x minus box. And this needed to be on our speed sheet today, which I forgot to print out. Oh well, I'll do it for tomorrow, hopefully, if I remember. All right, Andrea, give us 2 values. Fiona will give us the third. Oh wait, we have a third person here. Teflon will give us our third. Yeah, where do they go? Is y minus 18, is that what you said?
Me?
Andrea, one more time.
Oh.
Yeah, do one more. You can either do the 12 or the 1. X minus 12 right here. Not quite. The thing that should be next to the y minus and x minus should always be the x and y coordinate. So our y coordinate was 18, so that went next to the y. Our x coordinate is 1. 1 should go here. And I'll label this. This is our x, this is our y. And now Teflon, what is the number that goes in our final remaining box?
12.
12. Easy peasy. If you want to annotate underneath these boxes, you can say under here that this is your m, your slope. But more specifically for AP Calculus, this is really our f prime, which is the way we've been annotating slope lately. That's our y1 coordinate. This is our x1 coordinate. So we know what each of those boxes means. Cool. All right, so we have our tangent line approximation. There it is. We're going to use that to approximate the snow at time 1.2 days. And I randomly switched from a T to an X here, and that's my fault. So let me come back and fix that. I'm going to change that X into a T. I don't know. I hate using the eraser tool because it randomly makes it mess up like that. So I'll say T minus 1. So that means that this also should be, instead of an X1, it should be a T1. Get all my variables in order here. Why does it do this to me? Scroll down, scroll back up. Oh, maybe I just delete it. I'll say that's our T1. All right, so at time 1.2 days, we just plug it in. If you want to go for it, tell us what to write out. Point 2 minus 1. Teflon, you're going to do some mental math for us. 1.2 minus 1 Teflon is
0.2.
0.2. Andrea, 0.2 times 12. 2.4. So now I have the new equation down here. Y minus 18 is equal to 2.4 using mental math. And Fiona, add 18 to both sides and you get Y is equal to 20.4. There it is, yeah. So if this could be represented as a line, which most things can never be, but if we could, then we would say it's approximately 20.4. It's an okay approximation. And if you study mathematics in college, they will teach you a bunch of other really good approximations instead of just using linear lines. Cool, yeah, so we would say 20.4. And then for these types of problems, we do have to be careful. We want to use our units. So 20.4 inches of snow, right? Because our original units up here said 12 inches per day. So our units here are 20.4 inches. Although if the problem doesn't specifically ask for it, then you don't need to write it, but just always be prepared. I want to draw a graph of what's happening in our pictures so that we can make sense of what's going on. So they gave us some initial information. They said at one day we have 18 inches. So that was just a point on the graph. So if I come down here, after one day, we can come up here to a height of 18, which is right about there. They give us that point. What else did they give us? They told us that the rate is 12 inches per one day. So if I come down here, 12 inches per one day, that means if I go down 12, this is originally the height of 18, right? I got that right? Yeah, 18. So if I go down 12, that should be down to 6, so right about there. So I can have that point. And then if I go up 12 from 18, because our slope again is 12, that's going to give me a height of 30, which should be in the next day. So 30 is right about there. So that's the line that was given to us. If we want to go ahead and make that line, shoink. I can make that a black line too. That's the line that was given to us, and we get to just plug in values to that line. So this next question down here, it's saying for the t value strictly between 1 and 1.2. So what values are we talking about? If I had to just draw a strict domain, I would say between, I want to use yellow here. Actually, I can use lines. Let me find my line tool. There it is. So strictly between time is equal to 1 day and 1.2 days. So in between here and here, what is S double prime, or we know that S double prime T is greater than 0. So on a graph of S, what is S double prime Teflon? Is it height, slope, and cavity?
Wait, what was it?
So on a graph of S, what is S double prime?
Concavity?
Cavity. So this is, and we can all write this down in their notes too. Oop, I didn't want to do that. We can all say that this means we are concave up. Concave up. It's just given information. Somehow the math gods have come down and told us S double prime T is greater than 0. Which means if I had the actual graph, what should be happening here, and again, we were given this point, we had to use a slope for that point, but what should really be happening here is I have some sort of a concave up. So it should be going up. And I'm doing my best attempt of making a slight curve that is concave up. So we approximated at time 1.2 in the last part up here. At time 1.2, we got 20.4, which corresponds to this point down here. I can say that this point right here, that is our 20.4. That was our approximation, but we used a line, which isn't perfect. So it's a very common theme in AP Calculus to approximate things with a line and then say, okay, well, with this extra information, is that a over or under approximation over and over again? So what is this? Is this red value, this height here, is that an under or is an over approximation? I'll give it to either Andrea or Fiona. Say it louder. Under, yeah. I mean, it's under that blue line. This blue line is more accurate because it's with new information. Our new information says it's concave up, and this is under the blue line. So we can come down here and say it's an under approximation. Under approximation, or underestimate. It's the same word. Or under approximation. Oh, what just happened there? Why does my computer do this to me? So I want to come up with a rule that will be able to tell us every single time if it's an under or over estimate. This is something that will eventually be added to the speed sheet. So that's the backside. Did I lose anyone? Let me come back so I can see Teflon. Fist of 5, how well are we following me for now? 4, 4, 4. All right, we haven't lost anyone. On to the backside. Underestimate versus overestimate. Wait, overestimate versus underestimate. I can read. So notice that this first graph everywhere is concave down. It's concave down there, there, there. It's always concave down. So we can say, let's just go ahead and call these graphs F. So I can talk about F double prime and say that's a graph of F, that's a graph of G, I guess. Notice on this graph of F that F double prime is less than 0. We're always concave down. So concave down. Can't spell here. And similarly over here on the graph of G, everywhere it's concave up. It's never concave down. So G double prime here is strictly greater than 0. It is always concave up. So I want to analyze a few different types of slopes. So go ahead and be ready to start drawing lines or tangent lines to the graph of F. So I'm looking at F prime. Let's go ahead and just randomly choose a point over here on the left. I don't know, right there, sure. And make a tangent line. And I kind of want to use the line tool just to be making my notes look nice. So there is my tangent line that could be better. It's because I have to hold the Option key to make that not stick to 45 degrees. There we go. There's my tangent line. Notice that this tangent line, and I can annotate this as well, this is an F prime greater than 0. The slope is positive. It's going up. So we're about to make a conclusion, but let me annotate everything that's going on here with a table. What we have in our table is we want to know what is F. I can do these color-coded too. What's going on with F prime? What's going on with F double prime? And most importantly, what's going on here with our approximation? Our estimate, I should say. I mean, you can say approximation estimate. It doesn't matter. Estimate is an overestimate or is an underestimate, right? Those are the only two options. Or is it exactly on point? But that's not going to happen for these tables. So, all right. So if we use that red line that I just made up here in the graph, so let me just choose a random point that's on that red line. If we chose that point right there, would our tangent line approximation, would this black point be an over or an under approximation, Andrea? This black point right here, would that be an over or an under approximation? Over. Everyone say over. So F prime over here was greater than 0. And F double prime is always going to be less than 0. It's going to be less than 0 for this table down here as well. What happens if I do a point on the other end of that Teflon? Is that going to be an over and under approximation on the other side of this?
Under?
It's actually going to be over because this black height is over the blue height. Because the blue height represents the actual function. This black estimate using this line is above the blue line. Let's try another one. Let's go ahead and make another tangent line. And hopefully you can predict what's happening before you even make it. So before I draw it, and hopefully before you draw it as well, what's going to happen over here on the right-hand side when I have a negative slope? You see what's going to happen? If not, let's go ahead and try. Okay, so go ahead and make your point of tangency. Draw your tangent line. You need to hold option so that it actually has the right slope. There's my tangent line, and I can make that a little bit better. And I'm going to use that tangent line to find any point on the left or the right. And Teflon again, any of these points are going to be over or under?
Over.
Again, they're over. Yeah, so again, concavity is still less than 0 because I'm talking about this graph. So concavity is less than 0. Now my slope is less than 0. It's negative, a negative slope. And my estimate is still over. Interesting. I've kind of used up all I can on this. Of course, even if my F, I guess we can do this one too, just to be careful. If I have the slope at 0, if I have my point of tangency right here at 0, again, it's going to be the same thing. So if my F prime is equal to 0, then my F double prime is still less than 0 because I'm talking about my first graph, and it's still an over approximation. Now is a perfect time to ask questions before we move on to our second and final graph. Yeah, okay, then we're moving on to our final graph. Let me extend these lines down here a little bit. So our second graph, it's concave down everywhere. So my G double prime is going to be greater than 0. So maybe this is changing to a G here, but that's fine. We're going to say it's greater than 0, greater than 0, greater than 0. So let's try to do the same types of slopes. Let's try to find a slope that is greater than 0, less than 0. And we don't need to because you'll see the pattern by then. But we can also do one that's equal to 0 to have a very thorough table. All right, so I want to try to find this table entry right here. So on this second graph where it's concave up, I want to find a slope that is positive. Where is a slope that is positive? It has to be over here on the right-hand side. I'm going to randomly make it right about there. And make my tangent line, move that to the right spot. All right, this tangent line, if I draw any points either on the left or the right on that tangent line, Fiona, is that going to be an over or an under approximation? Again, it's going to be under. Well, not again. For the first time, it's going to be under. Let's change our point of tangency so that we have a negative slope for this second point down here. I'm going to randomly choose right there. Make a tangent line. And my tangent line could have a better slope. Teflon, is that going to have an over or an under approximation?
Under.
Under again. And Andrea, what do you think is going to happen when it's set equal to 0? Under as well. So now is the time where you get to analyze this table and tell me a generalized rule. When will you know if you have an over approximation or an under approximation? If Fiona has an idea, we'll let everyone else analyze the table. If I told you the slope, the height, the concavity, all of this information, how would you be able to figure out if it's an over or under approximation, an over or an under estimate? So Fiona has an answer. Andrea has an answer. Did you figure out Teflon? Yeah, okay, let's hear Fiona. Go for it. There it is. Write it down for our notes. This is a speed sheet result right here. F double prime greater than 0. It's going to be an under estimate. And you can remember these however you'd like. Like if you think F double prime less than 0, it's concave down. Down is the opposite of up, and up is like an overestimate. I don't know how you guys want to think of this. Every time that I get confused, I have to remake these graphs. So if you ever look at an answer key and you see like weird curves and lines happening on the left-hand side, it's because I forgot if it's an over and under estimate, and I'm remaking these graphs. That's where it all stems from. It only depends on its concavity. It does not depend on its height. It does not depend on its slope, only if it's concave up or down. Oh yeah, so sometimes you will have a graph of F prime and they will Actually, I've never seen one of those questions where they give you a graph of f prime and ask you if it's an over or an underestimate. They'll always give you a graph of f, typically. But maybe I'm wrong. Maybe there is one out there and I just haven't seen it. That's it for our lesson. That is lesson 4-2. Can you guys all give me a, or girls, I should say, no, there's no Chris here. Can you girls all give me a fist of 5 for our objective? Can you use a tangent line, approximate values, and determine if it's an under or an over estimate? 5, 4, 4. All right. That concludes the notes.